So as promised, this is a quick update on what geology is working on in the background of the CDI. If you've been in the meetings, then this should all be familiar to you, but we wanted to make sure that everyone in SS&T was on board and understood what we had planned in terms of a vision. So from the beginning, we've been thinking about how can we use the opportunity of a Center for Innovation to innovate our teaching, and specifically to deal with elements pedagogically that we have struggled with. In fact, all geology programs struggle with. So basically, how can we embed learning opportunities into the design of a building if we were going to design it from the ground up, which we are? So to give you the context of what is problematic, in geology, we deal with things that exist on very large scales, but the laboratory setting itself only gives us access to things you can hold in your hand. That does not capture the reality of the variation that exists in the real world, and in fact, that students will encounter in the real world. This is an example in front of you of a single boulder, but of course, this extends to the outcrop level. And interpreting things on that scale requires understanding how things change laterally, vertically, etc., at those scales. And this is the same really anywhere in the world you are going to be. So extending not just from a boulder or an outcrop to learning how do you conceptually connect outcrops through space and time, working in 4 dimensions to be able to tell these broad narratives about the history of a region or of the globe as a whole as it changes through time. This is conceptually very difficult. So one of the challenges we deal with students is that they have to learn to visualize and to think in very novel ways and in very novel scales. At the same time, they have to learn the tools that we have developed over the past 200 years to present these kinds of ideas in diagrammatic form. And this is an example in front of you, a cross section of the entire history of the maritime provinces as represented in their underlying geology. So how we normally do this is in paper and pen exercises where they work through a series of relationships, in a hypothetical cartoonish outcrop, which takes them through a series of different steps of change and challenges them to untangle this. So this is certainly functional, but it is not as good as actually getting out in the field. The problem is the field is not only expensive to access, for the vast majority of the year, it is inaccessible due to weather. Not all students have the same desire to get out in the freezing cold as us geologists do. So there's been a trend to utilize the campus itself as a proxy for that outdoor environment. So to build into the landscaping geological materials that create public learning opportunities as well as supporting these aspects of the teaching that I've been describing here. The wonderful thing about this is mostly unused space. It's space that exists simply as a access to a place or the literal structures that hold up a building. We're utilizing those for teaching. It's also wonderful in that it not only erases those economic barriers, it erases or at least significantly reduces the physical barriers to field education. So what does it look like? Well, there are 4 kind of big themes in this kind of movement. The first is to utilize physical walking spaces to represent geological time scales. That as you move through space, you are moving through time. And there's a couple of examples down below from the Grand Canyon and from a school in Virginia Beach. The second is to utilize geological materials in a conscious way so that if you're building infrastructure anyways, utilize not just random materials off the shelf or cement, but where possible, geological materials that can serve a dual function. The third is to integrate geological materials directly into the landscaping themselves. So what would be in place as simply aesthetic objects can also be functional in terms of teaching. So there are a lot of different examples of this. And again, one of the wonderful things about this is that rocks, to be frank, are quite pretty. And so we can utilize the landscaping for passive science education, informal science education, as well as using it directly in our curriculum at the same time. And there has been research on this. I can provide more links if you want to see how effective this can be in terms of both outreach, but also in terms of providing basic field school skills to students. Maybe the most innovative, though, is to actually emulate outcrops themselves on campus by utilizing wall environments, either externally or within the interior of buildings. This takes something we normally do on a 8.5 by 11 sheet of paper and transforms it into something that represents much more closely the actual experience of being in an outcrop and utilizes real geological materials in addition to those geometric relationships. So perhaps the best example, the most innovative example of this is from Lone Star College in Texas. In construction of their building, they created a three-story, three-dimensional rock outcrop so that students could develop those spatial skills in the same way as they would in the real world, but without leaving the building itself. The wonderful thing about this is it's not only an effective teaching tool, it's a very effective recruitment tool. Despite being part of a large network of colleges, Lone Star College, this particular campus, graduates more geology stream students than any other campus in their network. They also have other universities coming to their campus to use their facilities. And I note that everything they are putting on the list right now are things that we are either proposing or we've had directly funded from the ACOA funding associated with the CDI. Our vision has three components: a rock garden, a timeline, and a multi-story interior teaching wall. These would utilize geological materials that would collectively tell a 1.5 billion-year story, a story that takes us from the dawn of eukaryotic life all the ways through to the very first fossil forest. These materials would be utilized in the landscaping, allowing students to be able to investigate large objects as well as taking measurements on them to be able to reconstruct in their minds the three-dimensional representation in a hypothetical subsurface and practice field skills. Those boulders would also be utilized in landscaping in the rest of the university, allowing the CDI to better integrate into the campus as a whole. We also envision a series of small plaques placed into the actual sidewalk adjacent to or in the perimeter of the building, which would allow visitors to walk the 4.5 billion-year history of the planet, stopping at major geological and biological milestones. This could be accompanied by small interpretive signs or QR codes to add additional information. The final and most ambitious part of this project is a 10-meter by 7-meter, two-story interior teaching wall. This would utilize the light well that extends in the new plan between the first and second level and would be conveniently located next to a stairwell as well as the Unamaki teaching lab. As you can see from this mock-up here, visitors on the lower level will be able to see part but not all of the diagram, requiring them to move to the second floor to engage in a full exploration, as well as still requiring a mental leap to be able to connect units from the top and the bottom, allowing them to work on regional correlation skills. This design would utilize a mosaic approach to cut back on costs, but utilize both paid or purchased and locally produced stone tile. If money allows, we also envision a third equivalently sized mosaic on the third floor, which would represent a cross-section of the entirety of the geology of the Maritimes from east to west. So how do we pay for this? Well, this is a big question. We have $150,000 from the CDI ACOA money. That is not going to pay for all of this. The nice thing about this, though, is all components of this are such visually striking and singular entities. It should be, we hope, reasonably easy to access donors to fund this project, but we will definitely need donors. Why are we bringing this to you? Well, at this point, we're moving into the concrete stage of discussing with architects. And so we wanted to reach out to you to see whether you have design suggestions that would allow you to be able to utilize these elements in your own teaching. We're also interested in any comments or concerns you might have about integrating these into the building plans. We welcome any comments, concerns you have. We welcome collaboration. Please reach out to Ted, Lillian, or I. Thank you so much for your time.